Can you see my screen?
Yes, sir.
Okay. For our lesson today, even our practical class is a bit short because it's not much too complicated to let all of you to understand. It's just only the way that we apply our mathematics. And I don't never observed that Microsoft Teams now they can like have the voice translations. You see in script when I try to talk something and then they translate. So I hope that what I'm talking they can translate well. Okay, so when we talk about dynamic system, we will focus on many options of dynamic system. So one of them is equilibrium solutions and its stability. So the next chapter we will talk about nonlinear behavior and linear behavior of dynamic system. And today we will talk only equilibrium and stability solutions. So the point of equilibrium solution we will talk about general definitions, practical case that we apply equilibrium solutions, and the critical point, stability, and some practical case that we will focus in our practical class today. Okay, it will sound quite different and difficult for you to sound like what is the equilibrium solutions. So it is a kind of solution that we use to find the one stable or unstable situation of the dynamic system that using differential equations and its derivations equal to 0 in this case. So as you see in this case, like you see in the picture, when you try to build one system, to model one system, some system can be covered or represented by one mathematical formula, and some can be used as a differential equations. So we use this equilibrium solution to show about stability of the system. When will our system have a stability? And when our system is unstable. So this is the goal general of equilibrium solutions. So when we try to focus on slope, the picture that you see in this figure is slope field, and it's a kind of visualization flow that shows us about the solution curve in our different equations. And in each point of the solution curve will be indicated in the slope. So normally when we try to focus on the slope field, it's a kind of the flow that we can distinguish how our system flow work. And also we can be able to we are be able to distinguish and find this about the critical point. In this case, the critical point is the point that make our system to be 0 in its derivations. So in this case, I would like to say in Khmer a little bit. នៅត្រង់ចំណុចនេះមានន័យថាសម្រាប់ critical point គឺជាចំណុចមួយដែលធ្វើឲ្យ system របស់យើងស្មើ0នៅក្នុងចំណុច derivation របស់វាអញ្ចឹងអានឹងគឺជាចំណុចរបស់ equilibrium solution. So in equilibrium solution in this case, what is the main point or the main keyword that you have to remember and pay attention is critical point, stability, and for its definitions you just read and try to just read it. It is okay. So how can we apply our equilibrium solutions to anything case, or what is its look like? So as you see in this picture, equilibrium point is a kind of equilibrium solutions that bring us the most important feature about the dynamic systems. And since we have to define it, what is the point in our solution that make our differential equation to be zero? And you see in this case, A note, when you see you try to focus, so this is one notion of equilibrium solution that so that you see like this arrow here. So this is the kind of solution that so to our system, our solution is stable. When it show out some this kind of arrow, it will show that our system is a kind of unstable. So as you see in this figure, it's just only the way that the first two-dimensional data that we will focus on, and then our system we will work just like try to use linear regressions. And if our equation like more high dimensional data, how can we make a representation like you see in the other figure on the right hand side? Is this kind of like spiral node? It can like a three-dimensional data that you see, and the representation in this you can see different points. So our data is the same. If you see a row, how to define the arrow that can identify the point is a kind critical point, you will see in the next slide. So how can we apply our equilibrium solution into the real case for nowadays? So as you see in this figure, it is just only one case that they try to apply in economic systems. So in our economic, why we can use this solution? So when we try to balance between the demand and supply for our customer, for example, I am the one in the company, and I try to study about the demand of the customer and how much supply that I can feedback to them. So in this case, when we try to focus about the price within our system is ranked or settled with the certified customer demand. For example, how much service that I should provide to my customer during these durations, and how much they demand. For example, during Khmer New Year in Cambodia, normally I am the owner of the supermarket. The rate or the figuration on the number of the selling rate in the company is different based on time. During our Khmer New Year, the amount of the selling rate is increased. So how can I study the way that I can produce or prepare in advance to supply the demand? So based on the data that we have so far from previously, or the data that we can apply with one mathematic formula to be a curve that you see in this picture. So we can use this kind of representative and using equilibrium solution to apply to identify the balance between demand and supply. And how about the other factor such as our factor, IT factor? So what is the solution in this case? We have one company named Equilibrium. It just bring the solution to be the name of their company. So Equilibrium partner now about leading technology company is to develop and deploy one best solution related to image processing. And they use this kind of spectrum technology to produce and use equilibrium solutions in order to provide a solution related to image automation and with automation. So this is one way that we apply the solutions to the real life. And how about the other? So when we talk about the business, we always talk about the cost. How can we identify our products cost? So we will focus on what did we expense and what will we expect to have income. So the way that we study those points we call cost effective solution. So equilibrium solution also can be applied into this kind of case. The way to engage of creating the model, how can we create a model, and IP protection assurance. So IP in this case is not internet protocol, it is intellectual property protections. We also can focus on electronic and physical security. I just give one example to all of you. When I was in my master degree, I have used one kind of method to identify the coefficient of my mathematical formula to see that it is a kind of coefficient that produce the nonlinear behavior in my system or not. So as you see that when we try to identify any number, so we can also use this kind of solution, equilibrium solutions, in order to identify the way that we can produce the security. Why I say like that? When our system produce something unstable, some people they also said, okay, your system is unstable, so it's not good. No, it's not like that. In some case, for example, if I work with the kind of the cryptography system, so if your system is like stable, the way that attacker try to predict your system is a little bit easy. But if your system is unstable, so it make the attacker be difficult to attack our system. So this is the advantage of using something stable and unstable. So how can we identify that our equilibrium solution that represented by the differential equation is stable or unstable? So you will see in the next slide. So before we go to the way that we can identify the stable and unstable in system, you have to know about the critical point first. So in easy way, the critical point is the point that make our differential equation equal to zero. This is the easy to understand one. So when you have the differential equations, so when you put the point into that equation, for example, I have fx equal to x plus 2x plus x squared, for example. So any point that make our fx to be zero, so that point we call critical points. So if our function is a kind of continuous function, so the result that we can take from our differential equation can be positive or negative. To construct the Pech diagram, in this case, you will see what is the Pech diagram look like. So we have two conditions. One is left arrow and right arrow. So when we have the value of our functions or the differential equation reach to be negative, we will draw as the left arrow. And if our functions or our differential equation reach to be positive, so we will have a right arrow. So you will ask me that, teacher, what is the Pech diagram and what is left arrow mean and what is right arrow mean? So you will see now. So in our critical point, if we have like a differential equation fx equal to kx in this case, so in order to make our function or differential equation equal to zero, so our critical point that we have find is kx equal to zero, so our x equal to zero. So on the left hand side, we have from the unlimited minus unlimited to x and from x to plus unlimited. So if the value that we take from this case from minus unlimited to 0 make our function to be less than 0, so it's mean negative. So our arrow is left, so we draw as a left. And if our value from x to the unlimited value, so at this from say x equals 0 to this value, make our equation equal to or greater than 0, it's mean positive. So we draw the right arrow like this. So this kind of arrow we call Pech diagram. So what is the useful of Pech diagram? So the useful of Pech diagram is the way that we can identify the slope field of our systems. So how can we identify the slope field of our system? So as you see in this case, we have two degree. I can say that the second degree of our equation. We have kx multiplied by m minus x. So if we have two value, we also can draw the Pech diagram as this figures too. So this critical point represent what we are called the equilibrium solution to our differential equations. So it's the point that can identify the stability of the systems. For example, if we have the solution of x of t equal to c, so c is the constant, that xt is kind of matrix, or we can call, if it's just only one dimensional, we can call it as array of solutions or array of critical point. If it's kind of two-dimensional or higher dimensional, we can call it a matrix of critical points. So you can ask me, teacher, how can we identify the left arrow and right arrow? As you see in the previous slide, in order to draw the left arrow, it means that all the value that can make our functions or can make our differential equation to be negative. So we draw left arrow. And the other why we draw right arrow. So how can we use this Pech diagram to draw the slope field for our system? So you will see now. So in our critical point, we try to identify that in which of critical point that produce stability, unstable or semi-stable or stable. So we have three conditions in this case, but before we go to the way that we can construct the slope of field, let's try to see the definition first. So for the technical definition of the stability of the critical point is that if we have, I just read the slide, the critical point x equal to c. So in this case, I just do not use like x of t because I assume that it's just only one critical point in our solution here, just only like a linear equation. We have only one variable and one degree. So if x equal to c is a kind of stable or not, if we have epsilon here greater than 0 and it exists sigma here greater than 0. So we have x minus c less than sigma. Apply that for all t greater than 0, we have xt minus c less than epsilon. So this is just only the way that we try to formula it in mathematical way. But the easy way, when you can see it in the practical case, I will show you the example that we can define what is the critical point that we can find from our differential equations. And it seems to be so like, teacher, it's too complicated for us to understand. But in this case, as you see that when we talk about the dynamic system, we always find the solution to apply in our dynamic system, especially for measuring functions. So in order to apply our dynamic system to different situations of the system, for example, what kind of stable system should be applied? So If it's a kind of the step ball, I have to identify that when my system is stable. So how can I identify that my system is stable? I can use like a critical point. Those critical point is a kind of equilibrium solutions. Okay, let me see the way that we can identify how to draw the slope field to our system. I assume that I have these equations. So how can that we draw the solution in this case? Okay, before I try to have 2 degrees, but for the first case example, let's see only 1 degree first. If we have our differential equations, in this case, I put x minus x. So in our theory, we call x plus c. So this is the same case. We have differential equation fx equal to k multiplied by x minus c minus h. So our critical point, in order to make our equation equal to 0, we try to take k multiplied by x minus h equal to 0. So our x equal to h. And then as we know that h is one value, is a kind of constant. So if the value less than h, it means that our equation or our differential equations will be negative. So if it's negative or positive, we will, in this case, when we talk about negative or positive, we will draw our phase diagram. So if you see in this case, I draw to this line and I draw to the other line to be like a contrast to each other. So if our h here is a kind of positive value, constant but positive, so our phase diagram here is incorrect because it contrasts to each other. But if our h here is negative, so our phase diagram here is correct. So how can I identify the slope field for the step ball point? So in this case, the critical point that can produce the arrow like in this figure. So it means that critical point in this case produce the stability for our dynamic system by using equilibrium solutions. So let's see in this figure, and you can forget about the way that I set the parameter here. So when I try to focus on solution here, so how does it look like about the step ball point? The step ball point, it's mean that all our solution that you see, like you see in this figure, you see the way that we try to build the diagram, and you see some small point here is a kind of flow of our system, and our system is a kind of flow that reaches to the value of this line. So this line is the value of x equal to 8. For example, I put the variable here is y. So it means that y equal to 8. So when y equal to 4, so we would like to see that our system is stable or not. So if when y equal to 4, it produces the phase diagram like this figure. So it means that it is stable point. And if you can plot it in the slope field. So when you see this figure, it means slope field. So it means that the value is reached to be the critical point. It means that those values produce the stability in our solution here. How about the other case? Let's see the other case. So in our solutions, it produces the same phase diagram, but you see at the moment is increased to the critical point, but in this case, it's decreased to the critical point. So our system is the same. However, it increased or it decreased to the step ball point. it will produce a stability the same for our system. So we have two cases. One increase to reach stable point, one decrease to the stable point. But both of them produce the phase diagram with this kind of diagram. So it's mean that the point that we produce is stable. It's not unstable. It's stable. Okay, let's see the other case. If you see the other case, it's mean that in our system, we always have the right hand side, right arrow, sorry, right arrow. It means that all the system, it produce like a positive value or case. For example, I have in this figure, as you see in this figure, I have our function equal to y square. It means that however the value of y is, it will produce all the system is like positive value. So when you see something like that, you see our value in this case is y equal to 0. And we have two graph to flow is one tries to lift the stable value and the other graph so that try to reach to the stable value. So we have one graph so that our system try to lift, I would like to say in Khmer, chạ chánh. It means that try to lift the stable value and the other graph try to show that our slope field try to reach to our stable value. So in this case, we call semi-stable. What does it mean semi-stable? It means that one part is unstable and the other part is stable. You see, one try to reach to the stable value is stable. One try to lift the stable point is mean unstable. So combined together, we call semi-stable points. So this is the case 2 that we try to identify our system or our equations. We have case 3. So our case 3 is mean that the contrast way from the previous ones. So we have all the our equation is to the left arrow. In this case, all the case is tries to lift our systems. What does it mean? It's the same case from previous one. One try to lift, one try to reach the stable point. So when you can construct the the slope field like this figure or like this figure, it means that the point that you can earn from differential equations is a kind of the semi-stable points. So the phase diagram that you can produce from this solution can be like this kind of a row can be like this. So if you have two cases like that, it's mean that your system is semi-stable point on N. How can we apply a kind of semi-stable point to the systems, the real case? Something our system that we try to produce for one dynamic system or one model of dynamic system. When you construct it, it produces kind of semi-stable point. So how can we make those things to reach to the stable or reach to unstable? You have to apply some constraints and some condition. If you ask me that what is the constraint to apply and what is the condition that we should apply, it based on what dynamic system that you are using now. So now you have to know about three cases. One case is about stable point. The stable point is the point that our slope field try to reach to the critical point. And semi-stable point is the slope field tries to lift and reach the same time. One try to lift the critical point and the other one try to reach the critical point. So in those cases, we have case 2 and case 3, we call semi-stable points. And how about unstable? How does it look like? About unstable, when we have the equation that show that your system is unstable, you can produce the phase diagram like in these equations. So if you have the system and the system different represented by the differential equations, and you can draw the phase diagram by this figure. So it means that your system is unstable. So how can we apply this unstable? Let you see and let you check in this diagram or this slope field. So we have the value of y equal to 4 here, but our system is trying to leave the stable point. So it means that our system is unstable because it cannot stay in the stability. It tries to reach out the stable point. So phenomenon of our system is unstable. So the same case in this one you see in the figure is try to lift the stable point by decreasing the value of the system. We can see also the way that can try to lift but by the increasing way. So now as you see that you see four case difference. One case, how can we identify the stable or critical points? We have four cases. One case is that our system produces the stability. Stability means that the arrow that you see from the phase diagram is try to reach to our critical point. So try to reach to our critical point. It produces two ways. One increase the value of the function and the other one is decrease the value of the function. But both of them is trying to reach the stable point or critical point. And we have two cases for unstable, semi-unstable point. It means that our system try to produce something like one one part of the system try to reach to the stable point and the other part of the system try to leave the stable point. So if you can see diagram something like that, you will be able to set up or to state the statement in our system that our system is semi-stable point or semi-stable system. And if you see in the forecast, case 4 in this case, it means that our system try to leave the stable point and they have to weigh the same. Sorry. So for our system here, when you have your system try to leave our stable point can be increased or can be decreased, we call our system is unstable. So every system, however in mathematics, however in our economic point, all the system that can be represented by differential equations, you can use this kind of equilibrium solution to apply to them. And for identify that our system is stable or not stable, we can use critical point to make to identify it. So for our critical point, we have three conditions. In our definition, we have four cases, but in our figure, we have three conditions. Is one, leaving the critical point. The other one, reaching the critical point, and the other one is one leaving and one reaching. So we have like stable, semi-stable, and unstable point. So I will show you about the practical case. Okay, let's see the sample of practical case that the way that we can find the practical critical point for our system. If I have the sorry a bit. Sorry, everyone. Okay, let's see the example here. If if you ask me, teacher, what system that can represent by differential equation 5 multiply x minus 5? It is just only the example. The real system is not like too easy like that. So some system can be like a differential equation with exponential, with convolution, with integration. So those kind of things we can represent by the differential equation. But for the example case or sample practice case, in this case, we try to solve up something easy. So for example, we assume that once our system fx represented by the equation 5 multiplied by x minus 5. So in this case, we have k equal to 5. So k is a constant or coefficient. So it's like something not different. So we just have our equation to be equal to 0. So our x equal to 5. So x less than 5, we can make our system is like less than 0. And if x greater than 5, our system is greater than 0. So based on those values, we can draw the critical point of our system is unstable. Why you say like that? So when our x here is less than 5, it means that it's negative. So we have left a row to draw in our diagram. And if it's greater than 5, it's positive. So we have right a row here. So based based on the value that we have now, the value that we have, if we try to plot it in the slope field, you will see, okay, all of our system is unstable. We just use only path diagram to identify. But if I would like to see in the slope field, sorry anyone, if you would like to leave, you just leave, but you will be absent in the class. And if you come back again, okay, just be patient. And in this case, we try to plot our slope field to see that how is the flow of our system. So if you have the equation something like that, our system is like leaving the step ball value. So leaving the step ball value is mean that if you use value of our y here, in this case I use x minus 5, but in the slope field I use y minus 5. So it just only we just observe that this one is x, not because you see here is dx over dt. So but this one I use dy over dx. So it's the same case, just different variable. So if you try to reach this point, this is the value we call critical point or stable point. And our system flow from the value from the stable, our system is try to leave the critical point. It means that our system is unstable. So in a word, in order to identify that your system is unstable or stable or semi-stable, you can just only try to use the path diagram like this. You can also identify, but in order to show the flow of the system, so you can use the slope field. The way you try to plot something like that, the point like this, you call it slope field. So the slope field can show the flow of the system. So in our system is try to reach out the stable point and by the this decreasing way. So this is the flow of the system. So I think I have only one practical case to show you here. So I think the lesson about the equilibrium solution, I have only this slide. So okay, Antoine, do you have any questions?
Yeah, so I just have a question. Uh, um, if I have an equation, who has this way, so a multiplied by x minus b, where a and b are constant. That means that it is always unstable.
Okay, if you use a kind of variable, we cannot define this is constant or not constant. Let I go to this one. You just use a and b, but in this formula here, I use k and h. Okay, let me draw something for you. Wait a bit. Wait a bit, everyone. Okay, based on our friend question here, if I have the equation fx equal to a multiplied by x minus b, so is this always unstable or stable? We cannot say. Let me say something for you. Wait a bit, I try to share the screens. Can you see my screen now? Sorry.
Yes.
Okay, so in your case, if I have our fx equal to a x minus b here, right?
Yes.
So in order to find the critical point, it means that you make this one equal to 0. So in this case, sorry, for in this case, we can reach that our x equal to b. If first of all, I do not plot it in slope field, I try to draw the phase diagram first to let you see. This is the value of x, and I put x b here. So if in case the real value, for example, I can say that okay, b is, you have two options, can be positive and can be negative. How does it look like when b is positive? So I assume that b positive. First case positive, I just put p here. In case that b is positive, when we draw the position of b positive, the value from here to here, it's mean that our system will produce a negative value. So it's mean that x minus b, it's mean negative because the value from here to here is less than b. So if it's negative, you will draw the left arrow. And from b from here to here, our x greater than b. So our system will produce like positive. So positive we draw is here. So in this phenomenon, it try to leave the stable point. It means that leaving the stable point, or I can say the critical point. So our system is unstable. For this case, do you understand?
Um, I agree with the solution, but I still doesn't understand with the previous one with the x no 5 multiplied by x minus 5
Okay, okay,
because it is
okay.
yeah sorry.
Let me explain in this page first, negative or positive first. Okay, I will show you for the next explanation, but the first try me to distinguish the positive this value first. For example, if b is negative, sorry, if b is negative, b is here, b negative here. So if b negative here, it means that in this case, if x less than b, so our value always produce positive value. If the value from here to here is always produce the positive. So the positive, we draw this one a line, right arrow. And from here to here, our B will produce a kind of like always. Sorry, let me I show you again. If the value from less than B, it will produce always positive. And if it greater than B, it's also produce the positive. So we always have like positive and positive. So in this case, you see, one try to reach the step ball and one try to leave the step ball. So in this case, we call semi step ball points. This is like one theory in general way. How can we apply it in the specific way? Okay, let's go to the specific solution that your question asks. We have our fx equal to 5. Sorry, x minus 5 here. So our solution here is mean that we try to make our fx equal to 0. What does it mean here? In order to find the critical point, we try to apply our differential equation to be 0, because this is definition of the critical point. So we can say that 5 x minus 5 equal to 0. So we can see that our x equal to 5. First, I try to draw the space diagram. Okay, x equal to 5 here. If the value of x less than 5 is from here to here, if x less than 5, our system always produce the negative value. You see, x minus 5. If x less than 5, it means that our system always produce a negative value. So our system will be here, left arrow. And if x from greater than 5, from this value to this value, our system always produce the positive value. So if it's a positive value, it means that you have the right arrow here. So in this case, it's unstable. Why I say it's unstable? For the phase diagram, sorry, when we have our system that try to leave the stable value or stable point or critical point, our system is unstable. This is like one notion of equilibrium solutions. Antoine, can you catch up what I mean here?
Yes, totally.
Okay, this is it's like a very easy case. As you see, when I try to produce something here, it's just only one variable. But the real system is not like that. The real system might like too complicated. It can be like exponential, can multiplication by like a 10 degree of linear regressions. For example, if you have like a fx equal to ax plus bx squared plus cx, for example, something like that. Some equation, it seems to be like something like that. If you ask me that, and what system can represent like that, I cannot find the specific solution or specific system to show you, because like a specific system is like too complicated. So how about the other? Do you have any question more?
លោកគ្រូអា critical point ហ្នឹងជាតម្លៃដែលធ្វើឲ្យ derivate នៃអនុគមស្មើ0ឬក៏ឲ្យអនុគមស្មើ0
When we talk about the equilibrium solution, it's a kind of solution or a kind of system that can be represented by differential equations. So differential equation, it is the first derivation of it's already. ចង់ឆ្លើយជាភាសាខ្មែរបន្តិច I would like to say in Khmer a little bit to explain the other guy. So នៅត្រង់ចំណុចហ្នឹងជាធម្មតានៅក្នុង system របស់យើងគេប្រាប់ឲ្យថា equilibrium solution ហ្នឹងគេប្រើប្រាស់សម្រាប់ system ទាំងឡាយណាដែល represent ដោយ differential equations អញ្ចឹងអាសំណួរសួរថាស្អីគេ differential equation អាហ្នឹងអា derivative វាស្រាប់ឯហ្នឹងយល់សំណួរហ្នឹងអត់អញ្ចឹងជាធម្មតា for example in this case, sorry a little bit, we have fx equal to integration of fx dx here. So if you can or you are be able to identify fx is stable or unstable, it means that it's the same case that you can identify fx is stable or unstable. Okay.
អត់សូវយល់
Okay, let me say in Khmer a little bit. យើងមានអាគម system មួយគឺ fx វាជា original equations represent our system. ដូច្នេះហើយសំណួរសួរថាតើយើងអាច identify ថា system របស់យើង stable ឬក៏ unstable. So make the យើងត្រូវការ find x. Find x ធ្វើម៉េច For example, y ស្មើ fx នាំឲ្យ f តូចរបស់វាស្មើគេ មិន derivation of y មិនអញ្ចឹងទេតើនេះយល់ទេ
បាទ
So ពេលយើងសិក្សាអំពី derivation របស់វា stable ឬមិន stable នៅមក system original របស់វាក៏អាច identify ថា stable ឬក៏មិន stable បានដែរអញ្ចឹងនៅត្រង់ចំណុចនេះមានន័យថាម៉េចនៅត្រង់ចំណុចនេះមានន័យថាដើម្បី identify ថា system មួយ stable ឬមិន stable ដំបូងបំផុតយើងយកអានឹងទៅ derivation ទៅអា derivation នឹងមូលហេតុអីយើងធ្វើ derivation ដើម្បីយើងរក critical point របស់វាអញ្ចឹង based on critical point ដែលយើងអាចរកបានវាអាច identify ថា system របស់យើងគឺជាប្រភេទ stable or not stable. Okay.
បាទលោកគ្រូប៉ុន្តែខ្ញុំឃើញលោកគ្រូឧទាហរណ៍មិនទៅអត់មាន derivate ឬក៏អាហ្នឹង derivate
if you ask me at the moment that is this our system that so at the moment is kind of derivate, you see that the system is dx over dt. You see it's kind of derivative one or not?
បាទហើយ
លោកគ្រូខ្ញុំសុំសួរមួយ
បាទ
នៅ slide ចុងក្រោយហ្នឹងលោកគ្រូអានៅកន្លែងទៅនេះcritical point យើងធ្វើមិនឲ្យ derivative ឲ្យស្មើនឹង0ទៅបានយើងមើលដឹងថាវា stable អត់ត្រូវអត់លោកគ្រូ
Yeah
តែនៅក្នុង slide នេះខ្ញុំឃើញលោកគ្រូបញ្យល់តាក់ទងជាមួយអានេះវា reach ទៅដល់ a goal វានៅ the top នេះ reach to the top នេះបានអាចដឹងថាវា stable ប៉ុន្តែអានេះវាលើស0ឯហ្នឹងលោកគ្រូវាទៅជានេះវិញឯហ្នឹងលោកគ្រូ
in case នៅត្រង់ចំណុចស្នូលយើងគឺដំបូងបំផុតយើងមិនឲ្យ our differential equation equal to 0 right
បាទ
so
អញ្ចឹង
when
x
our
មក
our x equal to 5 so in order to study and to learn the value of x cannot be only 5 x can be less than 5 and x can be greater than 5 right
បាទលោកគ្រូ
so all the value that x less than 5 it make our differential equation value is less than 0
បាទលោកគ្រូនៅពេល less than 0អញ្ចឹងវា semi stable ត្រូវអត់លោកគ្រូ
no if we cannot identify that it is semi-stable we have to show all case so in this from x less than 5 our system is less than 0 it means negative if it is negative we can draw the left arrow you draw first and then we study the other value x can be greater than 5 so if x greater than 5 our system always produce the value is positive so we draw the right arrow so we as you see this arrow it means that our system is try to lift you know lift L-E-A-V-E
ចាក់ចេញពីកន្លែងតំណឹងលោកគ្រូ
yes it try to lift the critical points so when our page diagram that show that our arrow try to lift the critical point it means that our system is unstable so this is the way that you can prove by the page diagram but how can I know the flow of the system you see the flow of our system is decrease or increase we cannot identify you have to plot the slope field so I try to input it in slope field so in our slope field as you see that in this case this is the critical point right x equal to 5 you see this variable is y but in I put here is x so you just okay y it's the same and you see x here is t this one is t sorry that I put different equation here so if you have here t here and this one is x we have our critical points or stable point is 5 here and our system is try to live you see by decreasing sorry by decreasing value see try to live by decreasing so it means that our system is decrease the value try to live our stable point so if you talk about some domains you can slope sorry you can identify the domain value of the threshold that you try to identify the system if your critical point is a variable in system so if x from here to here it will decrease the system but if x from here to here we do not know exactly yet we have to see it
លោកគ្រូខ្ញុំសូមឲ្យលោកគ្រូជួយបញ្យល់ case 1 ម្ដងទៀតសម្រាប់ case 1 ហ្នឹងវា stable ត្រូវអត់លោកគ្រូ
yes so can I find something in stable way
លោកគ្រូខ្ញុំសូមសួរមួយបាន
okay
លោកគ្រូខ្ញុំចង់សួរថា ហេតុអីបានយើងចាំបាច់ឲ្យ n x នឹងស្មើ0ដោយសារតែយើង dx នៅលើ dt អញ្ចឹងបើសិនជាយើង d អនុគម n x ទៅវាមិនស្មើ5ដែរអញ្ចឹងមានន័យថា f' នៃ x ស្មើ5តែចាំបាច់ហេតុអីបានយើងចាំបាច់ dx ហើយស្មើ5 x ដក5ហើយបានឲ្យ n x ស្មើ0អញ្ចឹង
okay. Anton, do you understand your friend questions?
No, not
No.
totally.
Okay, his question is like, can you try to ask in English to make your friend understand?
For my question, why we need to like we have n x mà dx nhân lợi dt equal to 5 multiply x minus 5. So why we need to tại ao đang gì vậy thế cô vậy là thay set with the sound
Okay, let me answer your question, because if I try ask you to translate the question, it's like already difficult. Okay, let's see in this diagram. Oh, I just show you in general case. Can you see the screens?
yes sure.
Yes.
Okay, when you talk about one equations, I just put it fx. I can say a little bit in Khmer. សិក្សាអនុគម the study of one functions. When I try to find, okay, I just put y equal to here. So when I try to find its derivation for the first thing, I just assume something like that. The first iteration, it means that you can identify how our system is up and down. So when you study in grade 12, you will see something diagram, for example, just only like this. It go up, it go down, it go up, it go down, it go up, and go down. And if you find the second derivations, sorry, it means that you try to find max and mean of systems. Can you catch up what I mean here?
Yes sure.
So if you ask me, if you have to make a derivation again, what does this mean? You do not find the the flow of the system. You see, the first derivation is the flow of the system. The second derivation is max and mean of the system. Can you remember something about your mathematics in grade 12?
លោកគ្រូចឹងមានន័យថាអនុគមដែលពួកខ្ញុំឃើញហ្នឹងនឹងជាអនុគមដែល derivative រួចហើយ
Yes. I do not know you understand.
អាហ្នឹងតនេះតែលោកគ្រូខ្ញុំសុំសួរមួយចាំតិចខ្ញុំមិននឹកសួរ
Okay. The other, do you have any question about your lesson today? So, okay, let me sum up again. First thing, wait a bit. First thing, you just only know about definitions. What is equilibrium solutions? So the property of equilibrium solution is critical point, or you can say that because our critical point can produce like three notion difference: stable, semi-stable, and unstable. And how can we identify those kind of these three notions. So about these three notions, we can identify by using phase diagram. So when something tries to reach the critical point, it's mean that stable here. Unstable, it means that tries to leave. When we talk about semi-stable, it means that one try to leave and one try to reach. So they have two cases in this case for semi-final. Semi-stable, one try to reach, one try to leave. Or you can say that this one. So this one is semi-stable.
Teacher, how can we define the arrow direction?
Okay. The arrow direction, they have two things. Okay, I just go to the next slide. Sorry. As you see at the moment, when we talk about the arrow direction, we have two directions. Is left arrow. One is right arrow. Any value, any value, any value of x that make fx is negative. Of x that make fx is positive. So when you use left arrow, it means that all the value of x that make our fx is negative. So we use left arrow. And if you have any value of x that make your fx greater than 0, you use right arrow. So based on this definition, you can draw phase diagram. Based on phase diagram, you can identify that your system is stable or semi-stable or unstable. But you cannot know the flow of the system. So to reach to the flow of the system, you have to use flow of system. You have to use the slope field. And how can you use the slope field? You will see later.
Sir,
Yes.
I think someone speak before me.
No one.
So what I was just thinking is what would happen if we have in the derivative function two solutions?
Two
If we
solution.
have like yes,
Okay. Actually, your question should be goes to the TP class, because in example, I have produced only one variable here, but in your TP class, you have two variables. Let me check for you. Wait a bit. So if normally our system in some environments, it can produce many kind of the stability status. For example, during this position it's unstable, during this position it's stable. For example, if I have fx dx over dt equal to k x minus x and x minus n. So in this case, the order of the n and x, you just, okay, you can choose plus, it based on you. In this case, I use minus because I would like to have x equal to 8. So I just use minus. So when we draw the Pech diagram, the possible solution you can, okay, just ignore the order of x because I put x the first, so I just put x here and n here. So the possibility of the system, for example, it can be something like this, or it can be something like this, or it can be like go like this, go like this, and like this, and it can be something like this. You see, all the notion. You see, this one is mean that it is unstable. This is semi-stable. So what is the use in this case? So when you try to identify some system or you try to make some system work, you have to put the constraint conditions. Why something like that? Because our system will produce different phenomenon if you use all. For example, if I use from minus is 1 to let's go to the next sketch. So if you talk about the values, if you talk this phenomenon, it means that you don't have the limitation of your system. It means that x belongs to this real value. Okay, I can say okay, this real value. So our system can produce different notion of the status, can be stable or can be unstable, or can be semi-stable. So if your system produce different notion during the value x equal to this one, you have to make conditions. For example, that okay, my function f, I try to apply in cryptography. So in one case of cryptography, I try to make like chaos, or I will try to make a diffusions, or I try to make something like that. Just only this chaos, diffusion, and refusion, for example, something like this. So it means that in order to make something difficult for an attacker to attack my system, I have to make my system is unstable to predict. If it is stable, it's very easy to predict. So my condition is unstable. I try to explain you in general way first, because if I go to the specific equation, you will understand only like a specific equation. So in general, I try to capture only something unstable. So if we have like our equation as previously, we have n and egg here, and the value of n and egg here, something like this. So if something like this, based on our notion here, the value that I can use just only from this value to this value. You know the reason why? Because from these domains, if you use something location in this domain, our system is stable. They cannot produce instability in the system, so our system cannot apply in cryptography. So the condition of x must be an egg here, for example. So must be n2 plus unlimited. That's why you have to make a segment of the system. You cannot use the whole domain of x or y or any variable here, because if the system produce different notions in one array of x belongs to all here, x belongs to all here, if it produce only one notion, it's okay. It's no problem. You do not need to make a segment of the system to make a constraint or conditions. But if produce different notions, you have to identify the constraint or condition of your system. And
Yes.
okay, do you understand?
Yeah, absolutely.
Okay, so let me show you not real, not real example. It's just only assumptions. Okay, I have the other assumptions. For example, if I produce teleport system, if something is not unstable, can I make it or not? You cannot make it. Your system must be stable. For example, human teleport. So if your system is not stable, can you teleport the human? You cannot. So you have to define the criteria or conditions. So in this case, I use condition, but technical way in the research or in like a general research system, you use the word constraints in order to make limitations of your system. So why you make a limit? Because you would like to reach your system to be stable. Okay, this is the way that you use the stable notions. And previously I apply in cryptography, I try to use unstable notions. And if you ask me, teacher, how about semi-stable? I have no ideas too, because I don't have any like discovery or a new finding that which system that we try to use as semi-final, as semi-stable. Just only system try to be stable and system try to be unstable. Just only these two cases. Okay. Do you have any other questions?
លោកគ្រូខ្ញុំចង់សួរ
Uh,
មួយ
Okay.
តាក់ទងជាមួយនឹង two variable យើងមាន 9 possible case right លោកគ្រូ
If your system conduct with two variable, normally your deviations can be a matrix. We can only focus one by one. If one case, in this case, you have to assume, okay, one value of one variable assumed to be stable. So you have only to study the other variable. You cannot like the same time, but you can, for example, you have to make like intersections. Do you know what I mean intersection here? For example, you have x and y. This is just only example, and your system over dt. So it's mean the x and y over dt. Right? Do you mean something like this?
yes sure
Okay. So if you study the same way, you cannot. You just only focus and only one by one. By assume that okay, y when you study about x, you assume that y is fixed. If you would like to study about y, you have to assume that x is fixed. So for example, in the page diagram, you have this notion. Okay, for example, you have 2x. And for example, in this case, you have different y. So you have to for example, for this value to this value, this one is stable, but this one is unstable. This one is stable. So for example, this one is stable. This one is unstable. you have to make a notion from here. So combination of the system, if x from, for example, I put this n here, n to unlimited plus positive belongs to ends here. N cannot be used if I use this kind of symbol, but if I use this symbol, it means n can be used. So x and y belongs to, I just put k here because I would like something unstable. So k and l here, for example. So h belongs to k and l. So our system is unstable. Can you see something like this? We cannot like study those cases in the same time when you have two variables.
I'm not yet get it, teacher.
No.
For example, this one we have to put X for static, right? Fixed, right?
When you try to learn or study about x, you have to ignore y, assume
Yes.
y is like one constant.
Okay. Now
And
in this case, I want to study about Y, so I put X
in
fixed.
the constant,
So X is stable, right? Can we assume that?
no, when you try to study one system, you have to study both, but you cannot study in the same time.
Oh,
What
okay.
do you know what I mean? So for example, can you draw the page diagram in the same time? You
No.
cannot. So first of all, you have to draw this one first, right?
Okay.
After that, you have to draw this one. So when you can draw this one, your system, for example, in this case, I try to produce something is unstable. So you have to make a constraint only the unstable condition. For example, unstable is from here to here. This one is unstable, right?
Yes. Sure.
So for our y from here to here, this unstable too.
Unstable too.
So but
Okay.
yeah, so we have n condition here. It means that h from, you see, h from here, from n to unlimited, it make our system is unstable.
Is
And
unstable.
y from here to here,
Unlimited. Unstable too.
no, not unlimited. You see this one is L because
Oh.
you have three value of y here. Let me draw the new ones.
Okay.
Okay. Okay, let me focus about x here. Our x, we have only two value, for example. I put a and b, and I put two notion, stable and unstable. Sorry. So in this case, I can identify 2 points. X belongs to ones to b. Our system is stable, right?
Yes. Sure.
So in this case, if it's stable, it's something like this. If it's unstable, something like this. So if x belongs to, normally, if you focus on these durations here, you cannot like, if it's this point is unstable, and you have to see first that from this location to the flow of our system. You have to check this. It is a kind of decrease or increase. Leaving the critical point, leaving the step ball point, it means that can be decreased or increase. So in this case, I just use assumption X belongs to A and sorry, is unstable. So, but the real value that we try to make sure that our system is stable, not stable, we will take from only B to this one is from B to minus 1. You know the reason why? Some combination of, because if you focus on A and B, B can be like a constant, or B can be like a matrix, two-dimensional data. So if it's two-dimensional data, some pair of value can be like from A to unlimited. Some pair value can be from B to unlimited. So to make sure that 100% is unstable, I will take from B. Why? But for A to B can be used. Some case can be, some case cannot be used. Why? You have to study about notion too. For example, I have 3 value and this is stable, and this one is also stable, and this is unstable. So you can take the value that is unstable. For example, if I have 2 unstable, so you can take the value from here to here and the value from here to here, and then you make AND condition. If it belongs to unstable, I just say unstable, and Y belongs to unstable, we get 100% our system is unstable. Okay. Do you understand these notions?
Yes, teacher.
Okay. You will see in example. No, not example. In our TP class. Because in the sample of practice, I put for you just only like, sorry. I just only get fx equal to dx over dt, sorry, dt equals to like kx minus x here. But for the real exercise, it's not like that. It's just only example to make you understand that you can, okay, based on this formula, how can I draw the phase diagram? And based on equation, how can I plot? So when you are in grade 11 or grade 12, you will use hyperbole and parabole to draw. But when you are in higher education, you have to use tool. So I will show you about the tool. You have to plot the slope field based on these equations. Okay. Okay. Other questions before we take a rest a bit?
So, teacher, one more last question.
Yes.
In this case, we could not estimate the like stable percentage of stable or percentage of unstable, right? We just know we have only semi-stable, meaning that it is 50% of stable, right?
We cannot identify the specific configuration or the value rate like you said at the moment. We cannot. Even like when we talk about the dynamical system theory or dynamical system theory method, it's a kind of the dynamic method. We cannot like okay, I try to identify it. Okay, my system is like 70% unstable and 20% is stable. We cannot say like that. We just only can identify, okay, if my value of the systems, we have two variable x and y, and then x from this values to the other value and produce the unstable. At least if have an operator, because normally to produce in one system you cannot x or operator, you have to use an operator. X can be something like, okay, our system fx, or I can say f x, because it's just only derivations. Stable while. That's why when you study about algorithm or coding, you have like a condition to put, because we have to identify the constraint. Stable during which conditions, unstable during which conditions. We just only do like that. We cannot identify, okay, 20% stable and 80% unstable. We cannot do. Or we can do in some case, but I do not know. I cannot confirm. Okay.
Okay, got it, teacher.
Yes. How about the other? Do you have any other questions? I think our lesson just only 45 minutes, but now it reached to 1 hour something. Okay. And
លោកគ្រូខ្ញុំ
okay.
ខ្ញុំសួរចង់សួរថាយើងរក critical point ដើម្បីបញ្ជាក់ថា stable unstable ឬ semi stable ចុះពេលដែលយើងរក critical point ហ្នឹងហើយតើសម្រាប់ទៅលើ system តើយើងយកវាទៅប្រើកន្លែងណា
Okay. Normally, when you talk about the critical point, critical points, I just put point with S because you can be multiple points. We can define system notions. Systems notions. So what does it mean notion here? It's like about, okay, stable and unstable, or unstable. So when you ask me that, okay, what is the use of critical point in our systems? Normally, when you try to identify the critical point, it means that you be able to identify the domain of the value that you can make it to make your system stable or unstable. For example, you have critical point, and this is one critical point. Duration of this one make our system is unstable or stable, for example. So you can use only this threshold of value to make your system is stable. This is the way that you can apply. I pick up one example case. I have one system cryptography for my master. I just use y x in I just use y. Y is output of ciphertext. I can say y of x, but okay, y. We have input x here plus yn here, xn plus a y n minus 1 plus b n minus 2. Normally, x is input, y is output. So our output, we have yn minus 1 and yn minus 2. So I have two variables here, a and b. So what value of a and b can be used for this kind of thing if I apply this one in cryptography? So in this case, I just apply in the real case. In this case, I try to produce the A and B we call coefficients. So our A and B must be something unstable or stable. So I would like to make our system is unstable. So I try to use the stable triangular. So if the coefficient is outside the stable triangular, if A and B is outside, I just okay, this one is A, this one is B. So the combination between A and B is outside the stable triangular. So that coefficient can be used. The stable triangle. So it means that coefficient can be used. So for example, if A equal to this one and B equal to this one, so when we make combinations, our point is outside stable triangular. So this coefficient can be used. But do you see A is outside stable triangular or not? No, A is not outside, but B is outside. So in this case, still can be used. And for example, if something like this or something like this can be used or not, cannot be used. You see, B is inside and A is outside, but our combination of matrix is still inside the stable triangular. The purpose of our system is outside the stable triangular, so we cannot be used. That is why you ask me that, okay, the value from both sides can be used or not. I said that sometimes can be used. For example, this is unstable. Notion of critical value. So if you ask me that, can we take from these values to this value? Yes, you can, but to make sure 100% is correct. If you have only one value A and Y, A and B, A or B, it's okay that you take all. But for example, to make 100% is incorrect, it means that you take value from this case too. Why? If A and B outside the stable triangular, 100% is unstable. So we can build something like this. You see, 100% is unstable. 100% is unstable. Add all the value that A and B is outside the stable triangular. This is the way that we can apply. If you ask me the specific system, I cannot say something specific. We can explain you in a general way, and I can capture this specific system to say to you because this is my topic during my master that I use like chaotic in digital filter, and I try to identify the coefficient of my second order equation to apply in cryptography. And if you ask me, is there the other equations? Yes, as you see in image or video processing automations, they use equilibrium solutions. But if you ask me how can I form up the formula, I will say I cannot, because the solution is easy to identify by myself, something like this. The research or the company cannot be created. It's too complicated to build those kind of things. The one thing of evaluation is that when you try to build one model and you try to scope those model in particular way, for example, I try to build a model of the dynamic system for unstable system. So you have the way to identify is using equilibrium solution in the critical point to identify the domain of value that can make your system is unstable. Can you catch up what I mean?
Yes, teacher. Okay, it's okay.
Yeah. Okay, the other.
លោកគ្រូនិយាយថាអាចមាន day array ហ្នឹងស្មើចំនួនថេឲ្យ
When you try to make a derivation equal to constant. It's the same case, guys. Let me show you. Normally, our derivation dx over dt can equal to any constant. Why we make it equal to 0? Because if it equal to any constant, we cannot find the critical point. It must to be 0 because we would like to find the critical points. Just only this. If you define some parameter equals to constant, so any constant can be produced. For example, if I draw something like that, x equal to 0 here, so the value of x from here to here can produce any constant for our dx over dt equal to c constant equal to the other x over dt equal to the other c constant. But what is the value constant? Constant here can be negative or positive. Negative or positive is the way that we can identify that our left arrow or right arrow. Okay.
Được con clear គ្រូនិយាយថា constant ហ្នឹងវាមាន positive and negative ចឹងទៅ
Okay, let me I will talk in Khmer. Sorry. ចឹងនៅត្រង់ចំណុចនេះសំណួរសួរថា dx derivation របស់យើងអាចស្មើនឹង constant ណាមួយអត់វាអាចស្មើ possibility មូលហេតុអីបើយើងដាក់វាស្មើ0មូលហេតុគឺយើងចង់ដល់រក critical point របស់វាបើយើងមិនដាក់វាស្មើ0យើងអាចរក critical point របស់វាបានទេវាអត់ខុសអីទៅពេលយើងសិក្សាអនុគមហើយយើងឲ្យ derivative មួយរបស់វាស្មើ0ដើម្បីអីដើម្បីយើងរកថាអាមួយ increase ក៏វា decrease ថ្នាក់ទី12ដល់ថ្នាក់ទី12យើងមិនត្រូវរកអីគេ up down up down មិនចឹងទេ
បាទ
យើងអត់ដឹងថាសិក្សា up down នឹងដើម្បីអីទេចឹង when you try to apply in the real case the first derivations you try to find the critical point it means that the first value we try to make our first derivation equal to 0 the same case when you study in grade 12 so នៅពេលដែលយើងមានចំណុច critical point មួយ the value from here system can be increased or can be decreased so if increase is mean positive if decrease is mean negative our constant just only this and how is the useful of critical point see based on critical point you can identify that our system is increase or decrease យោងទៅតាម critical point របស់យើងអាចបញ្ជាក់ថា system របស់យើងកើតឡើងឬក៏ថយចុះចា៎កើតឡើងថយចុះហ្នឹងហើយគឺជា constant របស់យើងដែលយើងចង់រកចំណុចណាមួយឧទាហរណ៍នៅត្រង់ចំណុចនេះប្រសិនបើវា negative វាមានថយចុះអញ្ចឹងបើ negative អូខេ negative ច្បាស់ជាដកស្អីគេមួយហើយដក variable for example ដក m ណាមួយតែប៉ុណ្្នឹងទេវាគ្រាន់តែ from this threshold of value make our system negative or positive តែប៉ុណ្្នឹងឯងអូខេ
លោកគ្រូខ្ញុំសុំសួរមួយលោកគ្រូ
បាទ
ទៅពេលដែលខ្ញុំរកទៅខ្ញុំឃើញតម្លៃវាស្មើ0ទាំងពីរតែអាហ្នឹងវាមិនវិញលោកគ្រូ derivation ឃើញ0
អូខេ
តម្លៃស្មើ0
I will give example to you Theo I have the x over dt equal to fx equal to kx squared so our result equals mean that x1 equal to x2 we have 2 degrees means you have two result, right? Nó bên data ស្មើ0 data ស្មើ0ទិន្នន័យរបស់យើងស្មើគេ
ឬដប់
ឬដប់អញ្ចឹងករណីនេះខ្ញុំដាក់តែ x ការ៉េទេអាច for example when we talk about the 2-degree equation okay, let me assume the other thing. Let me say sorry, cancel. Do not use get, don't save it. So when I talk about ax squared plus bx plus c equal to 0, when we have like fx equals something like this, so it means that we have x1 and x2, right?
Yes.
So based on data, so in case our friend asks if x1 equal x2, it means that our data equal to what? 0, right? So in this case, I just eliminate this one. Sorry, equal to 0. So it means that our equation we have ax squared equal to 0, our x equal to 0 here. So what is the slope value? Any value of x besides 0 make our system is positive. If positive is something like right arrow here. So based on the figure, my system, what is the type of my system? Just know. If I have this kind of phase diagram, what is my system? Stable, unstable, or semi-stable?
Semi-stable.
Yes, it is semi-stable. You see, you have two value here. x1 equal x2 equal to 0. This is a very easy example case. Okay, let me show you in the diagrams here. Okay. Can you see the slide I share? I don't know, the page.
Yes.
Okay, let me show you here. For example, if I have 5x squared, 5y, I just put y because the variable that they use here is dy over dx. So I just would put y here. Square. What is the slope value here? In this case, we can see that our system is produce something here. Why it's so up only one? It's try to reach the stable value. So because the solution that they can take here, we have many solutions here. You see, one try to leave, one tries to reach. មួយព្យាយាមចូលមួយព្យាយាមចេញអញ្ចឹងសំណួរសួរថាដូច page diagram ដែលយើងទៅមកគូមិញអត់ចាស់សំណួរ Yes, the same case. So I will send the links to all of you because this link can show up the I can see. So the slope field because if you try to plot it in your programming language, I would say it very difficult. Even MATLAB or even Python or anything. Because we have one organization is GeoGebra. GeoAlgebra is a kind of way to something plot. And I pick up one lesson by Mr. I do not know is the name of the tutorial. This is Dr. Arian Janet and it's about slope field plotter. the topic they discuss about is the calculus. So I just use this one to pick up the equation and put it to see the slope field. So can I identify the actually you have many solution here, but the solution cannot be be up all to the solution. We have many solution. You can draw from this page. You see, you can draw from this page, and you can draw from this page. So if they can, but the limitation of the solution, for the solution you have only A, B, and C. You cannot identify more than this solution. So because it's the existing tool, so we can make only something like this. This is the way that you can learn about the slope field, but how can I draw the page diagram? The page diagram you cannot draw by the tool here. You have to draw by your hands, systems. So this is one practical class. Okay, do you have the other questions? Okay, you keep silent. So if you don't have any question, oh, okay.
Teacher, can you give example of drawing the crop?
Drawing this graph, right?
Yes.
This is example of your friends. 5 multiplied by x squared at the moment that he said that he tried to x1 equal to x2 equal to 0. For example, if I try to pause the graph as our example, 5 multiplied by x minus, I just put y because it's the y over the x, minus 4, for example, it means x minus h. So if we plot it in graph, you see, this is the kind of the value that they try to reach out, not reach to. It means that lift the step ball value. So our system is what? When we have, see, this is unstable by the skin value of y here. This is the other example of our practical case with one variable. We cannot define two variables here because when you have two variables here, you have like a combination of the slope. The system cannot make, and I cannot draw it by imagination too. So we will focus only one variable system. Okay, let's have a rest for 10 minutes. We will come back again with our debate class. Okay. Let
Okay, teacher.
okay, let's enjoy the break. Okay, sorry. Okay, can anyone mention my name in your group of Telegram, maybe, please?
Done, teacher.
Okay, okay. It's a slow field plottering. For our TP class, okay, anyone have a rest? Just only rest. I just only mentioned something. For our TP class, it's just like very easy to three practical test equations. And the first one, I will make example for you. And the other two, I will ask to your friend to make example. And after that, you will see your assignment. Your assignment is the other research work, because as you know that it's oriented course learning. So I cannot ask you to build a system. It's like build one system is not like 1 day or 2 weeks you be about to build. You just only searching the existing system, and then you try to understand those system. No need to build it. Just try to understand existing one, and then make a short presentation.
លោកគ្រូសុំសួរមួយ
But
បើអា critical point យើងហ្នឹងមាន2 value អាហ្នឹងយើងគិតមិនលោកគ្រូ
okay. 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 TP. You have two Y, right?
Yes.
So you will see. You see, at this one you have only 2, but this one you have how many you have?
At
least
least
4.
3 or 4.
4. Yeah, at least 4. So in example, I give you have only 1, but in the real practice you have at least 4. And this one, for the last one, can you? The equation number 1 and equation number 3, if you just only ignore the power, the value is the same.
Teacher, for TP exercise number 1, we just pick up the value of critical point, right? We don't need to
No. You do not just pick up, you have to calculate it, make it equal to 0, and then you find the value.
yes. Yeah. So how about positive and negative number? We don't need to calculate it, right?
If you do not make it, can you draw the page diagram?
Oh,
And this
okay.
one you just only ask to draw the slope field, right? Based on
Yes.
our system, our slope field cannot distinguish all the case. So in order to define the instability, you have to draw the page diagram. Because as I told you that the limitation of this solution, you see, they have only like 4 solutions to so Earth. So 4 solution is not enough. you have like a multiple population here, like a 10 population. So some case you can like a show in a possibility solution here. But in this case, it can show only 4. So if it show only 4, you cannot identify the real, how can I say? For example, in this case, I try to increase the rate. For example, I choose power to 2. You see, when they have for the other value here, our solution here, we can produce many kind of the slope point. And if I try to decrease here, the value is not correct. So to identify the stability, you have to draw the pace diagram, because this kind of slope plotting cannot show all the answer.
Teacher,
Yes.
okay, you can go first.
ខ្ញុំមើលអត់យល់អាកន្លែង B ស្មើដក 2.64 ណាហ្នឹងបានតម្លៃមកពីណាលោកគ្រូ
ណានេះមែន
បាទ
នេះ
បាទ
app point value ដែលគេដាក់ឲ្យយើងហ្នឹង okay, they show us that when our value try to change នៅពេលណាដែលវាព្យាយាមដូរ value to reach អាហ្នឹងអារបស់យើងដំបូងមិនត្រង់មិនអញ្ចឹងហ៎
អូកើត
អូ
កើត
ខេ
ទេ
ហើយសំណួរសួរថាវាប្រែប្រួលនៅពេលណាគឺប្រែប្រួលនៅពេលដែល B ថ្លៃនឹងស្មើប៉ុណ្ណឹង
ប៉ុន្តែបើសិនជាយើងគូសដៃលោកគ្រូយើងអាច
you cannot when you draw by your hand previously in grade 12 and grade 11 when you try to draw something a graph something exponential something like that you try to use hyperbole and parabole actually you do not produce the exact point of the system the wrong it actually it's an assumption នៅពេលដែលយើងប្រើពួកអានឹងគួរមិនមែនយើងកំណត់បានចំណុចជាក់លាក់ដូចក្នុង system នៅក្នុង in system when you put some equations it produce exactly point that you try to produce but when you try to use by handwriting you cannot go through the exact point ពេលយើងគួរអា system មែនទែនណាយើងមិនអាចយើងអត់អាចនេះ produce point នឹងជាក់លាក់ឯងក្រាបរបស់យើងច្បាស់ជាវាអាស្រ័យតាម parabol អាស្រ័យទៅតាមដៃដែលយើងគូមិនអញ្ចឹងឯង
បាទអញ្ចឹងដល់ពេលក្នុងទេពេលលោកគ្រូគាត់លោកគ្រូឲ្យ drawing the sphere ហ្នឹង
យើងក៏យកសម័យកាលមកដាក់ខាងក្នុងនេះមកវាចេញហើយ slot field ហ្នឹង
លោកគ្រូសុំសួរមួយ
បាទ
សុំសួរមួយទៀតអា x min x max នេះយើងកំណត់វាយក
អា slot
range វាបាទហើយបន្ទាប់មកយើងដាក់សម័យកាលនៅderivative ដល់ពេលអញ្ចឹងទៅយើង set value នៃ y មិនទៅដើម្បីឲ្យវាបាន critical point
ជាធម្មតា critical point when you put the equation inside here they will produce the critical point for us you see here this is a critical point when you see like the first arrow here is a critical point in first case I don't want to share this kind of graph for you you know the reason why when I share this one for you when I try to produce the exercise here to calculate the critical point you do not make it just put the equation in that application they will show you about the critical points but one thing that difficult is define the stability so okay we can start early so you can finish it early we can stop our class and you can rest for your weekends
លោកគ្រូខ្ញុំសួរមួយ
បាទ
slope field ហ្នឹងលក្ខណៈជាមេកុនមែន
slope field ត្រង់ចំណុចនេះវា if you ask me what is a slope field mean in our slide we already identified the slope field meaning is the way that we can identify the flow of the system Okay, where I put the slope field. No, not this one. Here. To construct phase diagram, slope field. Okay, let me say to you, when you try to define the slope field, it means that you can see the flow of the system. So what is the flow of the system? And you see in this case, you see the slope field, this one. This is the flow of the system. So it means that our system is dropped down. So it will be dropped down like this. For example, if I limit this one to 50, it's more bigger. So it's 50, it's too big to see. It just only like increase the rate of our slope field. So in this case, if you ask me about slope field here, may in our theory that we study from our grade 9 until grade 12 is Mekon practice. But when we talk about this one is coefficient. Yes, your assumption is okay, correct. B chia variable មួយដែលយើងអាច pick up បាន for our equation of this curve. To build this curve, you can take this one to build this line. But when you reach from B to this value, you cannot use the line function. You have to use the curve function here. So what this mean curve function is here.
យល់ហើយលោកគ្រូ អរគុណលោកគ្រូ
Okay. Just say again. I feel surprised for all of you that on my class now I get more attention from all of you that you try to understand about the system. But previous year and like your senior, when I try to show to them about, I do not show something mathematics like that. I just only show them to about the theory. They know nothing about that kind of thing. So during this year, because I am a little bit far from you, and I cannot just only make introduction to you, just only theory. I have to make some practical case because I do it online. And also some case that really mathematics. I know some all of you pick up print screen from my teaching class and then you post in public way. It's okay. I feel so surprised that you feel abstract in my class. It is like the way that we try to imagine something, because when you talk about technology, you build one program. Your program is system. We identify the system. Normally, when you try to build something, you do not draw the system representations. You just try to build by the requirement, and the feature inside the requirement is already the plug-in of your implementation code. So when you go to the higher education for master PhD, you will try to build some sample of the model, some sample of the system. So the system can be represented by anything. Some system represented by the model by using graph, some system using mathematical formula. For example, especially in the term of information security in cryptography, most of them is mathematics. So it represented by mathematical equation. If you ask me that, okay, what kind of the equation should I apply? I cannot say anything. You know the reason why? If I can say what kind of equation can be applied, so I can create my PhD now. Any equation can apply, but the produce of the result is different. So we have to identify how much accuracy of the output that we would like to have. That's why we have to identify the system structure. So to build a system structure, you have to make a research. Research 1 year cannot be complete. You have to make 2 years. 2 years cannot be met. 3 years or 4 years.
លោកគ្រូសុំសួរតាក់ទងអា process តាក់ទងមួយការ research ហេតុអីមិនត្រូវការពេលយូរម៉េច
Okay. Your your friend asked me about the question that why the research take long time? You try to make up something new, update something. If you know something to do, it's not the research. The research is mean that you do not know what it is, how to make it, and you try to build it, you try to predict it, you try to make something to it. So assumption on something is not 100% be true all the time. So you test first, you get error. You have to test and research more until you get the sufficient result or effective result. So if your first experiment or your first test, you get the better result, you are a very lucky guy in research. I say you are lucky. I do not say that you are very clever. Research some case is like something to predict, something to estimate, something to make experiment. So when you try to formula some formula, you try to predict, you try to estimate what is the output of this experiment. You have to design your experiment. And if you have to build something, you have to make a literature review and research from existing one. And if you cannot make new, you have to modify and then update it. So modify some work and update it, it takes time. Shortly in Khmer, research without take time ដោយសារអីជាធម្មតានៅពេលដែលយើងធ្វើ research វាមានករណី3សំខាន់ទី1 literature review ការងារមានន័យថាយើងអត់ធ្វើអីទេយើងគ្រាន់តែមានបញ្ហាមួយអញ្ចឹងយើងទៅរកបញ្ហាជំនួយពិភពលោកតើបញ្ហាមួយហ្នឹងគេដោះស្រាយដោយដំណោះស្រាយអីខ្លះយើងទៅសិក្សាលើដំណោះស្រាយទាំងអស់មកយើង release ដំណោះស្រាយគេជា document មួយមកអាហ្នឹងគឺជាប្រភេទ literature review ការងារមួយចំនួនទាក់ទងនឹងការ update មានន័យថាយើងអត់បង្កើត solution ថ្មីទេមានន័យយក solution ចាស់របស់គេមកដដែលដល់យើង update ឲ្យវាល្អជាងមុន find something new it mean that you produce the new solutions យើងបង្កើត solution ថ្មីដោយខ្លួនឯងដោយមិនបាត់យកការងាររបស់គេមកដាក់ឧទាហរណ៍ Newton គាត់បង្កើត Newton he create new theory about the falling gravity so he can formula mathematical form physics and mathematical formula about the gravity so if you are a new philosopher you can create new formula so it is new thing that you can make it that's why research takes so long time អានឹង
លោកគ្រូ
research បាទ
សួរមួយទៀតបើឧទាហរណ៍យើង research ទៅលើ system អីចឹងបើយើងអត់បាន result អាហ្នឹងមានអីកើតឡើងគ្រូ
Okay. Your friend asked me about one question. If I do a research about the system and I cannot get a result, what is the effect? What is the impact? You will be fail. Just only this, the result. Normally, study about one system. For example, you would like to study about one system called weather predictions. So if you have the data, you try to learn and build a system and your system can produce just the same result as current solutions. So they have no any not I can say that effective solutions or active way that update your system more better. One thing you can just make a literature review and then so that your system can produce the same. It also the part of result can be published. If your system is better, it means that your system can be replaced to the existing solutions. ចំណុចត្រង់ចំណុចហ្នឹងបើសិនករណីយើងធ្វើការ research លើ system មួយហើយ system នោះយើងបង្កើតថ្មីខ្លួនឯងអញ្ចឹងយើងអាច compare system របស់យើងថា system របស់យើងអាចមាន performance ល្អដូច system របស់គេបើសិនបើយើងអាច update អីថ្មីមួយបានទេ still be good at least you make your own system but បើសួរថានឹងល្អអត់ល្អទេបើយើងបង្កើតអារបស់ដដែលជាន់មួយគេហ្នឹង you have reinvent the same wheel of the other So you have to update something, modify something to make something new. Okay, let me go to our topic class. So
លោកគ្រូឈប់ខ្ញុំសុំសួរមួយទៀតទៅក្រាបមិញតិចលោកគ្រូ
okay.
លោកគ្រូតកតងជាមួយអានេះយើងដាក់ formula ទៅយើងបានអាចំណុច B នេះ slot field
B just your friend said it's just only the coefficient of the graph.
coefficient ចុះលោកគ្រូអាចំណុចដែលត្រង់នេះវាជា critical point right
This one is the critical point here.
បាទហ្នឹងហើយអាហ្នឹង critical point យើងចង់មើល value វាបានអត់លោកគ្រូ
You see here, this is the value here.
ខ្ញុំមើលអត់ឃើញលេខ4 Okay got it មើលអត់ឃើញវាទូចពេក
Okay
អូចុះអា input នៅខាងក្រោមហ្នឹងអីគេ
What is input here?
អត់មានអីអា
ក្រោម
ក្រោមនេះលោកគ្រូតាមគេបង្អស់
Input here. For example, I put 5 here, 45 here. It's nothing here.
តែហ្នឹងគេដាក់មកទៅអីបងគ្រូ
In the formula of this kind of tool នៅក្នុង tool មួយនេះ in this kind of tool you don't have not only one equation here because of this author they try to take you about the calculus and differential equations. That's why you can see in the page, but actually you have a lot of things here. So okay, I can put a GeoGebra here. You see, in our system here, you have many lecture about mathematics. You have the calculator of the suite. You have 3D calculator. You have geometry. You have graphic. So the application is the same. It's just only way that you identify. Okay, I make a start calculation. You see, you have the graph and you can input different algebra here. You have the tool here. Draw a line, draw something. You have a lot of things here, but for our case here, because we just only use the slope field, that's why I pick up the cost. Because if you identify from the first state, we cannot build. You have to follow the cost by the other. So slope field នេះមានគុណប្រាប់ទៅ But the purpose here, we would like to know the flow of the system. We do not want to know about the coefficient. But when you know about the coefficient, you can construct your system well. Okay, let's see step by step. The first exercise, you have our derivation. We call y minus 2 and 1 plus y here. I just try to plot the slope first. So we have y minus 2 multiplied by y plus 1. So what is the result here? So we have two answers, right? One is y equal to minus 1 and the other one is y equal to 2. So this is our slope field plotting solution. You see, we have solution. One reach to the value and one leave out the value here. So this is the slope field explosions. So how about the result? Okay, I will draw the result for you because I have touch pad. That's why I can build a path. So if you ask me the answer, let me share you from here. Can you see here?
Yeah.
Okay. the first one, we have our fy. I just put y here. Because x equal to t, just put y. We have y minus 2 and y plus 1. It's easy, right? Y equal to 2 and y equal to minus 1. All right. So I would like to identify that in both critical point, which point produce stable and which point produce unstable. Let's draw phase diagram. -1 and 2. If I put the value from here to here, if y from minus unlimited to -1, our system is negative or positive?
Negative.
Negative.
So you can replace the value to the system if this one less than -1. So this package equal to minus, right?
Yes.
Minus and minus and minus. And this one equal to minus. Minus multiplied by minus. Positive or negative?
Positive.
So it's the right arrow. See, you make the wrong answer. Okay, if from -1 to 2, positive or negative?
Both. I don't think both, teacher.
Negative, I think negative.
When you put like this, you have to put this count. See.
លោកគ្រូយើងយកតែតម្លៃ between ទេ
Between only.
Yeah, negative.
I think it's a positive value.
So y
Negative.
minus y minus 2, the value is less than 2. It means that it must be
Negative.
negatives. And y plus 1, in this case, less than -1, it means that all the way positive. So positive multiplied by negative.
Negative.
Negative. So you will get the
Stable.
left arrow. So in the critical point -1, it produces what here?
Stable.
Stable.
Okay. How about number 2? If it's greater than 2,
Positive.
all the way positive.
And
So this one is unstable.
unstable. So in conclusion, what should we do, teacher?
In conclusions, when you try to build a system, so the value of x, if you capture from this value to this value, your system is unstable. It's stable, sorry. And this one, unstable. During this one, stable or unstable, it based on the combination of 2 points. This one between this one and this one between this one. If your value only once, so we cannot say that it's stable or unstable. If your system reach to this value, it means normally your system is over time period. So if the system reach to the value, your system is mean that from unstable reach to stable. I can say, you see, okay, let you observe her. -1 is unstable. You will see in the plot field later, and 2 is unstable. So let me show you about your assumption here. When you build one system, the value of from minus unlimited to -1, it means that your system is stable here. If you decrease from 2 to -1, it means that your system change the state from unstable to stable. From 2 to plus. This one I use this one. So your system is unstable. This is the assumption that you asked me at the moment. What is the assumption after we get the value? So if the value from 2 to -1, our system will try to change state from unstable to be stable. And if you reverse the process, -1 increase to 2, it means that our system change the status from stable to unstable. This is like a downside. If you put -1 to 2, it means that our system from stable to change the status to unstable. Okay, let us check in our slot field. So in our slot field, as you see, the value equal to 2 is what equal to 2? Unstable, right? Unstable, it means that our graph or our system try to leave the stable value or critical point. You see, try to leave, and it reaches to -1. Reach to -1 here, it's mean that it try to leave from unstable status to be stable status. The same in this case, it try to reach to the stable one. So if you would like to have exactly stable, you have to pick up the value -1. If you have to have exactly unstable, the value you can take 2 here. Okay, do you understand for the first questions?
So to define the notion of the system, we need to
Draw the
depend
slot field.
on
The slot field.
the system condition.
Yeah. To define the notion of the system, we define on based on the system condition, and the system condition you can know about its flow by the slot field here. And if you would like to build a slot field to identify that which point is critical point is the unstable or not stable, you can observe by this one. But because of the solution here, we have only 4 solutions. So you see at this you have only see the reaching out graph, but you don't see the reaching out this way. Actually, you have, if you have the other solution EFG, perhaps you can see this one too. Increase by reaching out. You see the slope here. So if you have more solution, you will see the difference from here too. But in this case, our application can show only 4 solutions. That's why you cannot see all the possible solutions. So you have to draw the phase diagram. Okay. Can you understand for the first equations? Hello. Okay. For the second ones, I would say I love number 8. I love number 8. So who will solve? If we see, we will count from me, and number 8 will be the one that try to solve the problem. 1, 2, 3, 4, 5, 6, 7, 8. Who can be say? Okay, let's solve the second equations. We have y square minus y minus 2 and 1 minus y square. What is the critical point? What is the slope field? So the slope field I can plot for you. So let's see the slope field first. So ours is y square. I will try to draw here. Sorry. We have like y square minus y minus 2 and the other one is 1 minus y, sorry, power 2. So you see the slope field is a little bit messy as you have like you have 3
លោកគ្រូគឺខុសអាសម័យកាលលោកគ្រូ
what is the equation?
Uh,
Let me check.
1 minus y
1 minus, okay, 1 minus, let me check. It's easy to find the slope field, sorry. Here, you have y, you can, because in here you cannot see equation easily, but you can see dy over dx square minus y minus 2, 1 minus y square. See the slope field that you saw, you have one solutions, but your solution here you do not have any graph. No, you know the reason why? Because the solution for here, they just try to draw here. So this is a slope field that you can see or you can produce by using geopra.org and in this course. But how about the page diagram? And what is the critical point? So the critical point, you see this one, and this one. And how about what is it, that value? So I will close it. You say, let's share screen and then show the answer. Chan Bisay, are you here?
លោកគ្រូគាត់ drop answer នៅក្នុង meeting.
He dropped the answer here. So you have to prove it, guys. So show your screens of your computer and make calculations. It's difficult for you to write note, but you can use mouse and then you open the notepad and then you can just write it. Open pad. Paint. So you can use your mouse draw. Actually, in my place, I have my, it seems to be like tablet. I use Surface, so I have a pen and draw. Pen, you know pen. You use pen so you can draw by mouse. However, just use pen, not printing. Pen. You know pen? Pen. Just write pen. P-A-I-N-T. A-I-N-T. Yeah. Okay. First of all, try to find the critical point. Our equation, we have y square in this case you just use touch and then you write equations. It easy. Okay, I can tell you one the other easy way is you use your phone and then you write by your head and then you take a photo here. It's easier. Okay. Besides, can you try to close it first? I will
Yeah.
share my screen here, and then you order me to do your actions. I am a robot now, so
Yeah, teacher.
okay. It seems like it's difficult for you to do it. Okay. Okay, I have the equation here. I just write equation first. What's next?
ឲ្យអា2ហ្នឹងស្មើ0លោកគ្រូហើយបន្ទាប់មកគេឲ្យ
Let's say in English because Anton here, so he have to understand the process too.
Let 2 of them equal to 0 and then try to find the grade y, yes, grade. For the first one is the grade b.
The second order equations.
The second order equation.
Yeah. So what is the answer for those ones?
Data.
You make a data. It's just like a small equations.
បោះបោះលេខ2ទៅខាង0នោះលោកគ្រូ
Can I write something like this? I do not know why you why you want to like
this one is okay. Equals 0.
you can find by based on data, but it's like it's too fine. It's the easiest questions, easiest formula. So for the first one, what is quality? Y plus 1 multiplied by y, right?
It's 2 1. No.
What is the value of y? -1.
-1, 2, and 4.
Y equal to
What?
because y equal to -1 is the same as here, so you do not repeat the result. Just only our equation is like a 4-degree equation, but you have only 3 answers because y4 and y3 equal to -1. Y1 and y4 equal to -1 the same. So you have 1, -1, 1 and 2, right?
Yes.
Okay, let's move to the you have Illinois here. I used to told all of you that when you join my class, please find the appropriate place because you will ask to join and do something to practice, at least to know that you can understand and find something. So our slope here, we have -1, have 1, and we have 2, right? So from here to here, what is the value of the system? Our system is
I would say positive.
okay. Let's see one by one. From minus here, this value all the way
0.
negative. Why you say I don't say -1? It's from minus this one to
Negative.
this one. So from this one, 1 minus y square, it always negative. Why? because from here to here can -2, -3, -4. So it's always positive here. 1 minus positive is in less than 0. So you have minus here. How about this one?
Positive, right?
From this case, if you would like to find the value possible greater than here, it must be positive. And you have positive multiplied by negative.
Negative.
So this one is negative. It will go to the left, right? If you would like to verify your answer, we can go to see the graph again. Do you see the slides here? When our value equal to -1, it's try to reach out. So the first value is okay, it's correct. Because it's left, it means we try to leave the stable value, so go out. It means correct. Okay, let's go to see. Okay, how about from -1 to 1? You say?
I would say negative.
Okay, let's prove step by step. From -1 to 1, from these locations, this place, we always say that it is positive because from -1 and 1 it's less than 1. When it's square, it more than less than 1. So 1 minus less than 1 is positive. How about this one?
I think positive.
You think positive? Okay,
Yeah.
let's prove it. Y square. If y square is less than 1, it means that y squared is always less than 1. Minus less than 1 and minus less than 2. So it's been always minus. So minus multiplied by plus here is mean negative. Yeah. Okay, let's go through directly to point number 1 here. If from 1 to 2, this one always negative. How about this one?
Negative 2.
The value of y always negative here. So negative multiplied by negative is positive.
Positive.
Yeah. And then how about if the value greater than 2? This one already minus, okay. If this one is greater than 2, always positive here. Because 2 powers is mean more than 4, and this one cannot be reached to 4. So in this one is
Positive, negative.
positive,
Plus.
positive, and then this one is left hand side. You see, value -1 here is what thing? Semi. From 1 is what is
unstable.
Unstable.
unstable. And about 2,
Stable.
stable. Let's check whether your answer is correct or not. Not okay. Do you see the screen?
ឃើញលោកគ្រូ
Oh, sorry. Let me go up and then I pick up the here. Draw it. When our value equal to minus 1. Minus 1 is something tries to one try to live, one try to reach, right? Minus 1. Minus 1 is your value is a kind of like semi-stable. It means that one stable, one unstable. You see, one try to, you see the figure, one try to live the value and one try to reach the value. The first one is correct. Number one is unstable, right? Number one is unstable. You see, they try to live here. Actually, they have to have the other graph here try to go up. But our solution have only 4 solutions. You cannot see it because the other solution they plot here already. So you cannot see even the above here. So the value number 4 is stable here too. Stable is mean that try to reach here. But you cannot see the plot here because the value of the solution have only 4.
លោកគ្រូអា plot ហ្នឹងអីគេលោកគ្រូ
Plot what?
មកអី plot
This one, right?
yeah
This one is slope field. The useful of slope field is to see the about system flow. You see, this one is decreased by leaving the critical point. This one is decreased. You see the here is decreased by reaching the critical point. And this one is decreased too by leaving the critical point. And the other you cannot see because solution cannot show all. If I have 10 solutions, perhaps I can see the other point number 2. Okay?
Yes.
So our result here, based on slope and based on path diagram, you produce the same result. So it means that your calculation is correct. But the problem is that at the moment I try to calculate something, the way that it's try positive and negative, you define is not correct. Some people, I did not say all, but some. Okay, do you understand for the second one? Yeah.
លោកគ្រូចង់សុំឲ្យលោកគ្រូបញ្យល់ assignment ទី2 អត់សូវយល់
នេះមិន assignment ទី2 For assignment, okay, just ignore assignment first. Assignment is the next task, step by step. Okay. The equation number 2 or assignment? Hello.
បាទលោកគ្រូ
Okay.
ខ្ញុំចង់សួរ assignment ទី2 វិញដែរ
Okay.
presentation
Okay, let finish our TP first. Okay. I would say I love number 2. Which one? Minh Chuang?
yes sir
Okay. Can you show me the plot of slope field of the equation number 3?
Number 3.
Yeah. So me share screen.
Okay. Wait. Wait a bit. Did you see my screen or not?
It's black screen now.
Wait a bit. Might be because of my internet.
You see, when we make example in the first, it's easy that you use only one variable.
So can you see my screen right now?
Yeah. Can you go to the, yes. The second one?
The third one, right?
Yeah, the third one, sorry. So the third one, you do not need to put 1/2. You just put exactly the equations.
Okay, it is
4 minus y.
minus y. 4 minus.
And do you have to put like a 4/3?
I don't know how, teacher.
Yeah, you have to put the
Wait.
parenthesis. If you don't put the parenthesis, you cannot make it. Multiply by 2 minus y. Oh, sorry, y minus 2.
Y minus 2.
Power is the SIP number 6.
6 number 6. Okay.
Yeah,
And
okay.
then
You just put the parenthesis 4/3.
4/3.
You put the parenthesis.
តែyou column មិនចេញខ្ញុំអត់យល់
Just use this one first.
Wait, let me enter
Parenthesis.
first.
Wrong. If you don't put the parenthesis, you do not get the correct one. You see?
Wait. Oh, a bit hard to control.
Yeah. It's open source tool, so I cannot say anything.
Okay.
You use okay. And use parenthesis here.
Okay, again.
Power.
First, this power 4.
Close the parenthesis.
Or be close.
Okay, after close, you just enter it. To see the equation you draw is correct or not. Okay, it's correct.
Not
correct already. You see the below equations?
Yeah, I see.
AY over AX. Yeah, it's correct. So you
Yes,
see.
Okay. The critical point is 4, 2. Yes, only.
Yeah, you have only 2 points critical. And then, can you identify which one is stable and which one is not unstable?
Stable or unstable, we need to
draw the phase diagram.
Draw the phase diagram. Okay.
Okay.
Now let me try to open Word.
Okay. Let's
I
see.
just to insert shape. Wait.
Okay. Let me draw for you, but you have to give me the instructions. I am a robot. Yes.
Okay.
Can you see the screen now?
Yes.
Okay, you have 2 solutions, right?
We have 2 and 4.
1 equal to 2 and 1 equal to 4. So if our value
less than 2.
Less than 2.
Wait, let me see. Let me calculate a bit, teacher.
4 minus y multiplied by y minus 2.
Negative. It should be negative.
So in this case, 4 multiplied by 3. What does it mean here?
រឹសទី 4 រឹសទី 3 នៃប្រព័ន្ធនឹងស្វ័យកូន 4.
Are you sure?
Yes, probably, teacher. I think so.
រឹសទី 4 នេះ
រឹសទី 3 គឺ
ទី 3
1លើ 2 រឹសទី 3 រឹសទី 3 នៃ
ហ្នឹងហើយ 3
ហ្នឹងហើយដក 2 ស្វ័យកូន 4 រឹសទី 3.
Okay, everyone, his assumption is correct or wrong? Incorrect. I just said this one equal to this one. Okay, it's correct. So when you have the value here, it means that any value here, the output must be positive. Every case positive.
Oh, okay.
You see?
Like
So this one, you no need
positive
to
thing.
just ignore it because always positive. So
So this one also
all
positive.
the sign here is based on the value here. So if the value is
Less than 2.
less than 2, it's mean positive. Positive is mean
Always positive increase
Always positive.
price.
okay. From 2 to 4.
From 2 to 4.
Also
Positive.
Positive.
positive. Greater than 4.
Negative.
Negative.
And you see the graph. This one is
Stable.
Stable.
and this one is
Semi-stable.
okay.
Uh,
Finish. To see our graph, can you see your graph again?
I see. Okay.
The slide. Yeah.
Yeah.
Okay. Can you see at number 2?
Yeah.
At number 2, you see is a kind of try to reach the critical value, but you cannot identify that it's stable or not stable.
Yes.
But you can see the float above.
The floor here.
No,
This one.
no. The sign ត្រេនៅពីលើ wheel.
This one.
Yes. Can you see
Critical point.
critical point and the sign above critical point?
This one.
Yeah. This is the way that you can identify that it is leaving the critical point from number 2 to go to number 4. You see, okay, let me share screen first. Okay, when you draw the diagram here, and then you always see something like this, and like this, and like this, right?
Yes, teacher.
Yeah. For the number 2 here, you see something like this. It means that it try to reach to this critical point. And above, you don't see any graph because solution us we have only 4 solutions, so they do not show us that the other graph solution, but they show us about flow field. You see the field here, something symbol like this. What does it mean here? It means that they tries to leave the critical point, but they have to go to reach the other critical point. And then a sign above, it tries something like this. It means that it's try to reach this critical point. So can you go to say your slope again? However, in the solution, you cannot see all the solution, but you can identify it by the flow of slope field. And you see the tray above, because not critical. Yes, this one. It means that they leaving from the first critical point to reach to the second critical point. And the highest ones, not critical point. Yeah, that's one. The highest one is they try to reach the critical point. So by observation, the flow like this, you can also use this kind of flow to identify your path diagram. Yeah, based on those. That's why slope field also benefit to identify the flow of our page diagram and the flow of our solutions. Okay?
បាទប៉ុន្តែលោកគ្រូយើងមិនដឹងថា direction វាទៅលើទៅក្រោម
Actually, for our diagrams, our friend asked that how can we know that our direction is go above or go down? If you have two critical points, for example, you have number 2 and number 4. In this case, from 2 to 4, you have to study about relationship. From 2, it leaving or it go downs?
អញ្ចឹងដល់យើងទៅរក face diagram ដែរនោះ
No.
Right.
Actually, based on this page, I can draw the diagram easily.
Okay.
You see, it leave from 2 to reach to 4. And above 4, it from the top, I do not know any value because it from the positive limited, unlimited to 4. Okay, let me show you. Okay, we have value. I can draw here. Sorry. I have diagram here. At the end, you have two value, right? 2 and 4. You know that the first solution, second solution, third solution, and fourth solution. The graph is try to reach to 2. From the bottom, it's mean from minus unlimited. It's mean that here is from here to here. Right? And from the unlimited to 4, it go down reach to 4. So it's mean that go down reach to 4. And from 2 to 4, you see at the moment it's leaving 2 to reach to 4. So our graph is here. See, you do not need positive multiplied by negative, negative multiplied by positive. No, you don't need. You just only the slope value. You can identify the page diagram. So this one is semi. This one is stable. Can you understand this one? And if you cannot observe it by your eye, you can use the same way. Is positive, negative multiply together. You get the result negative or positive. Okay. Can you catch up?
Look through.
Okay, we have only 3 practical case exercise here. And please let me know if you would like the other exercise to practice. Or you can take these 3 equation to practice against. So for our submission, our class, our TP, it's not this equation because I don't want you like to draw by hand and then take photo to make a submission. It's like, it's not useful case. So our assignment is to submit. It's just only 4 page of the slide. So find any practical case of the system. That our system is a kind of system optimized using equilibrium solution. Any kind of optimization system. For example, I use equilibrium solutions for image optimization, for example, or I use equilibrium solution for traffic optimization. Just only example. I use equilibrium solution for routing path optimization. So make a small presentation of 4 page slide, and then you can choose any sector: economic, IT, medical, biography, geography, any field as you want, but it present about the term of optimization. Any field, any sector, but it must be in term of optimization. And what does it cover for our 4-slide page? Page number 1, overall of system. For example, I use for image optimizations. So for example, I put the name of AG system, just the name. AG system is the system of A, B, C, D, E, F, G that produce the result to reduce something from status A to status B, for example. This is a kind of overall of the system and produced by who make it. This is the first page of your slide. And then you have to answer that why equilibrium solution is needed in this system. How system work? You can draw any diagram, or you can just use a touch to the. You can draw one diagram to represent the system flow, or you can just use a text description to show about the flow, input and output. And for the last one is about like a discussion page. If there is no equilibrium solution, so what will happen in your system? Is there another solution can have? So if you don't have equilibrium solution, so any solution can be have to produce the same system as equilibrium solutions. So this is your assignment to work, and then convert PDF to your PowerPoint to be the PDF and make a submissions. The rule of your submission is if you're copying from your classmates or missing to submit. Some people are lazy. They say, okay, I don't want this assignment score, but the story cannot be finished. If you don't submit it, or you copy from your friend, the next chapter of the class, the one that do that action will be the instructor. So for example, the next chapter, we will talk about the transform functions. So you can go to check in advance. The next chapter, we will talk about transform function. So I just only pick up the first transform function is the Z transform. It's the easiest one, the original one of the transform. And then I will pick up the vowel transform for the practical update of Z transform. And then we will see why we need transform functions. What is the useful of transform functions? And when we try to update to vowel transform, what is the useful and what is the change and why we need the vowel transform? So this is the next chapter, for example. And if any one of you missing or copy your friend to be the submissions, you will be the class instructor. So I would like to classify in our Khmer language. សម្រាប់គ្នាយើងនៅពេល submission សូម submit ជា PDF ហើយបន្តមកទៀតប្រសិនបើយើង copy ពីមិត្តភ័ក្តិរបស់យើងទោះបី topic the same ដូចគ្នាក៏ដោយក៏មិនតែមិនក៏ copy ពីគ្នាឬក៏គិតថាអូខេខ្ជិលអត់ចង់ submission ទេ assignment ហ្នឹងអត់យកបន្ទុកទេ story អត់ទៅបញ្ចប់ទេអ្នកនឹងត្រូវបានជ្រើសរើសជា instructor សម្រាប់ next chapter. Okay, do you understand about our assignment?
លោកគ្រូអាច pick up practical នឹងយកមក example តិចបានអត់លោកគ្រូ
Okay, practical example. At the moment, I just told you about benefit first ones, but you cannot pick up it because I pick it as example already. About supply and demand of customer in marketing. So what is optimization term? Optimize mean that I try to optimize the supply based on the demand of customer. So it's mean that to balance between supply and demand is a kind of optimization system. This is one term already. Overall of system. So I just put the name of the system. So okay, system AB system. AB system is the system that used to optimize the supply of ABC company to the customer needs in the duration of Khmer New Year, for example. And it had been produced by company in the year of and this company produce this and apply with 10,000 customer and get benefit of $10 million per year. This is the first page. And then you ask me about the second page. Why equilibrium solution in this net? Because we use equilibrium solution to find the coefficient, to find the rate of the coefficient to balance between demand and supply of the company to the customer by equation ABCD and equilibrium point ABCD EFG. System flow. We put the data from all data from the system and then put to the system and try to find the coefficient of the equilibrium point, and then we generate the output to see the balance, and is it a balance or not based on the system. And then if there is no equilibrium solution, what it happen? So can we find the one effective coefficients? It depends on your system. I cannot say yes or no. I have to go to see the description of the system. Okay?
លោកគ្រូសូមសួរមួយទៀតពាក់ព័ន្ធនឹង why equilibrium solution is needed in the system ហ្នឹងយើងត្រូវបញ្យកផ្នែក math អីទៀតអត់កន្លែងហ្នឹង
Something, yeah. I will say.
shit.
It's not shit here.
Sorry teacher.
It's not difficult. If I ask you to build, I say it's difficult. But it only asks you to learn about existing. It's the same in research that when you have the one problem, you have to make a literature review. So this kind of assignment is a kind of literature review only. I give one clue to you. Research paper is the easiest one. If you go to pick up search in Google and say that equilibrium solution for optimization task, they will release all the existing system, but it's very hard to learn their system. Why I say like that? Because this system is a kind of business system. They do not show all the property of the system to you to learn. But if you go to the publication, paper research or journal research, you can search those paper in ITport e-libraries, Google Scholar, Spring, Scopus, and then you will check the paper, and then you can see mathematical formula, you can see the description, you can see the goal, and you can see also the flow of the system. Okay? Do you understand about your assignments?
Yes, Professor.
Okay, good. How about the other? Do you have still have any wonder or misunderstanding some point that you would like to clarify?
គ្រូសុំសួរមួយបើកន្លែងខ្ញុំ explain ម៉ាត់ហ្នឹងបើ explain ខុសអីទៅលោកគ្រូ
You explain wrong, you will get low score. It's logic here. Okay? Do you have Okay.
អត់យល់បញ្យល់ជាកណិតមិនយើងទៅសេដូចថា system ហ្នឹងត្រូវការអនុគមហ្នឹងអញ្ចឹងយើងបញ្យល់អនុគមហ្នឹង
It's not something that you have to explain in mathematical way. It's some term, it's just like because of equilibrium solutions, you can find something. That's why it is needed. You know what I mean?
អត់តាន់សុំដល់ទៀតគ្រូ
Okay, let's say in Khmer. ដោយសារតែយើងប្រើប្រាស់ equilibrium solutions. That's why we can find out ABCDD in this system. Without ABC in this system, we cannot reach to the goal, for example. it's not compulsory that you have to explain in mathematical way. You just know that why equilibrium is important in this one. And if it is missing, what is the output and what is the outcome from the system, and is there any other solution that come up with the same problem but use different solutions? You based on your problem.
Okay, teacher, I got it. Thank you.
យ៉ាបញ្ហាត្រង់ចំណុចហ្នឹងមិនកំណត់ថាយើងត្រូវតែបកស្រាយតាមកណិតទេយើងគ្រាន់តែ state the reason why អា solution equilibrium របស់យើងហ្នឹងវាចាំបាច់នៅក្នុង system មួយហ្នឹង
បាទលោកគ្រូ
ហ្នឹង if you try
t-
to solve it mathematical way, okay, up to you.
One more question about the
Yeah.
system flow. Is it the explanation of the slop field?
No, the system flow is the whole system processing from initial state until final state. For example,
Is it include the input, teacher?
yeah,
You have to
for example,
describe the inputs.
yep. For example, M3. You know M3?
3.
M3. If I talk about B3 binary tree, you have only 2 leaves, right?
Okay.
Yeah. If I say M3, you have multiple leaves, more than 2. So for example, I have only B binary tree. So in this case, if I would like to use like routing optimization by using binary tree, it means that I will reach out to the leaf that have the smallest value. So it means that the smallest value is the way that we can find the shortest path. So you just drawing the flow of those kind of things. How does it work? Only this. For example, in web development, you try to build one application, for example, purchasing. So what is the kind of use case diagram or activity diagram to represent those flow?
Okay, so in our case, we can just use the activity diagram.
Yeah, you can just use case diagram, you can use activity diagram, or any kind of unofficial diagram. For example,
Okay.
if you say like, okay, I use case diagram, you name your diagram is use case, but the way you draw is not use case, your answer will be incorrect. And if you say that I use activity diagram, but the way that you draw is not activity diagram, your answer is incorrect. But if you use that, okay, this is a workflow diagram. So any diagram is possible that can express and explain the customer to understand your sewing. Okay?
Yes, okay, teacher.
Okay. And Anton, do you understand about the purpose of assignment?
Yeah, sure.
Okay, great. Sorry. Sorry. Okay. Everyone, do you understand about your assignment?
Yes, I will try my best.
Perhaps you can say, I'm going to try my best. If you say, I will try my best, it means that
Yeah,
not 100% that you will try.
I'm going, teacher.
Okay, this is okay. And the next chapter is about transform function. And I cannot pick up all transform functions. I just pick up 1 or 2 transform functions to show you. And I would say that something mathematics will come up again. And the related work is about convolution sum and transform functions. After the transform functions, you will, in the course syllabus, you have midterm exam, but for my course, we do not have the midterm exam. You will have the project descriptions and the group divisions. You will work by groups, and then you will have the topic to do some project. And I would like to say to you that your final exam is your presentations. Because I am here, I cannot go to control you to hack exam. If I put just a theory to ask you what it is and how does it work, you will copy one by work together to find a solution. So the best way for me to generate a score for you is to do the project. Personal responsibility and the group responsibility. So we divide by those kind of scores. Okay, if you do not have any questions, so please enjoy your weekend and your assignment submission platform will be created today.
Aku no
Yes,
problem.
teacher.
Okay, see you everyone.
លោកគ្រូassignment ទី1នៅ submit បានអត់
I don't remember what time. I think
នេះ
yesterday.
ហួយ
You can still submit it, but it will be late, too late.
Okay, that's enough. Thank you, teacher.
Okay.
Okay.
Okay, bye bye everyone.
Bye
Bye.
bye, teacher.
Weekend.
Yeah, thank you. Bon weekend.
Weekend.
Bye teacher.
Voilà, semaine prochaine.